everybody, and welcome to Elastic Observability Keynote. My name is Tanya Bragin, and I'm the Vice President of Product Management here at Elastic. In the next 40 minutes, we're excited to tell you about the latest product innovations and future initiatives in this space. But before we introduce our speakers, let's quickly recap why observability is so important. Many of you are facing challenges as you adopt new technologies to deliver your business-critical applications. And so you're looking at new ways to observe them and be successful in delivering them. This is causing you to look not only at new technologies, but really rethink how you approach people and processes around your delivery initiatives. And one important concept we hear about in these conversations is how critical data has become to making sure you're successful. It's looking critically at what data you collect, but also how you connect the dots, not just visually, but also using machine learning and other statistical analytics technologies so that your analysts aren't just staring at screens all day, but really are getting insights brought to them at the right time. We're really happy that in the past year, analysts in this space have recognized Elastic as one of the thought leaders. For instance, Elastic was named a visionary in the 2021 Gartner Magic Quadrant for Application Performance Monitoring. We're really excited about that. Elastic was also named a leader in GigaOM Radar report for cloud observability. And Elastic was chosen as EMA's top 3 for automatic end-to-end observability. This is great, but equally important are the conversations we're having with you, our customers. These conversations include, what does it really mean to have a comprehensive observability solution? Can it really be possible to cover all of my important applications and connect the dots from a root cause analysis perspective? The importance of ad hoc access to data to ask any questions and get answers back fast. And also openness. How do we achieve this in a flexible way, keeping our options open and making sure that we're embracing all of the ecosystem? All of these topics are very important for us at Elastic, and we'll hear on each one of them shortly. First, I would like to introduce Alex Fedotyev, product lead for Elastic APM. Alex will talk to us about what it means to have a comprehensive observability solution, and he will show how it's possible with Elastic Observability. Alex, please take it away.
Thank you, Tanya, and hello, everyone. I'm very excited to share what we have been working on and key priorities going forward. Often vendors in our industry have been referring to 3 pillars of observability as traces, logs, and metrics. But what does it mean for SRE, service owner, or a developer? For example, as SRE, you typically own a lot of services running in the cloud or hybrid environments. This could be multiple Java or Node.js applications, various backends like SQL databases or Redis cache, messaging services, or even third-party or open source projects. And you have to manage those, ensure their high availability and performance, and troubleshoot the root cause of critical problems. That is why we have been focusing on improving and unifying end-to-end experiences from onboarding to root cause analysis to bring relevant, contextual, and actionable information when you need it, leveraging all data sources. This timeline represents only a subset of the most important features which we delivered in just a year since last ElasticOn. The amount of innovation here is simply incredible. Let me pause for a moment and say a big thank you to our engineering teams who have been working on hard to deliver all of these amazing improvements to the observability solution. Awesome job, team. Let me do a quick demo of few features which I'm personally using multiple times a week when analyzing performance of our own applications, which we use for dogfooding. For those who watched the keynote, I'll try to go beyond some of the features Tanya demonstrated and get into interesting details behind the curtain. Let's start. Before clicking any further, let me introduce new additions to our family. First, OpenTelemetry is a first-class citizen we introduced earlier this year with ability to monitor end-to-end traces going across services instrumented with OpenTelemetry or Elastic APM agents. And second, iOS Agent, which has been in tech preview for a couple months now. We're collecting feedback from early adopters like some of you on our path to GA. We have been reimagining our user experience by focusing on investigative workflows and make it easy to spot changes and patterns and identify important actionable insights. My favorite feature is the ability to compare performance to historical, whether that is 24 hours or 7 days prior, which we nailed. Notice here that services are performing similarly comparing to yesterday, but the advert service is having a higher error rate and is unhealthy. We have been rolling it out across entire APM user journey to allow comparing everything from top-level KPIs to individual transactions, errors, backends, or even individual instances. Another major initiative was to bring contextual logs to the user, whether that is for the entire service, which is important for both containerized environments and those running on VMs or physical hosts. You can see logs per individual container or pod here too. Or even for the individual end-to-end transaction, which occurs when a user opens a page or an API call is executed. Here, we're able to show individual log entries for each step of the execution across all services involved. And one of the most exciting and recent features, correlations, which leverages power of Elasticsearch and brings incredible experience of analyzing and correlating traces. It helps uncovering unknown unknowns and find why your transactions are slow or failing. Each entry here represents a cluster of traces, which first of all were slow, and more importantly, have this unique value highly correlated to the slowness compared to the rest of them. Last one to mention is a totally new experience to understand external dependencies or backend services. Some of these dependencies are the backends like databases or caches or cloud services, while other could be the services which you just didn't instrument with APM agents yet. Now you're able to analyze both current and historical performance of each backend and their impact on the upstream services. Now I'd like to share a preview of our priorities, which we will be working on to deliver even more comprehensive observability solution. I'll start with logs. We're doing a number of improvements to make logs even more useful to our users. While being a leader in logs monitoring, we're challenging ourselves to uncover new possibilities and improve user experience by bringing contextual logs to the users when they need them. I just demoed how we enhanced application performance analysis by introducing logs across the APM UI. We're also going to bring logs to our new dependencies view. This will allow to quickly troubleshoot problems introduced by those backend services, like databases or cloud services, which every application depends on. Next, we are going to help understanding whether any of the services are running on properly sized and scaled infrastructure and have enough resources to operate by bringing infrastructure metrics into the services view. The plan is to make it work for containerized and cloud services, as well as VMs and physical hosts. Just imagine the ability to spot problems with some of the hosts and jump right into the metrics UI to understand what is consuming resources and discover something like an unbounded container or a CPU-intensive process. Similarly with logs, backend services or dependencies, which I demoed earlier, will gain new possibilities by connecting with infrastructure metrics. Today, you're able to understand when a database or another backend service are causing user experience to degrade. In the future, it will be possible to immediately see the state of infrastructure those backend services are running on and troubleshoot any problems happening there. We're also investing even more into root cause analysis and will up-level important insights using benefits of Elasticsearch to run complex aggregations, apply statistical analysis, and the power of machine learning. Important request we heard from you is the ability to compare service performance across versions, cloud regions, availability zones, and other metadata. This feature would help with comparing performance between A and B or canary deployments, verifying and troubleshooting issues which happen during upgrades, and more. And finally, ability to automatically categorize contextual logs for your application and backend services so you don't have to dig through the log lines. This is an existing feature already implemented in the global logs UI experience. By bringing it into contextual service and backend log analysis, it will uncover insights like new message categories, pattern changes, or rare messages. This is really unique to have a single UI instead of using multiple screens or even multiple tools to understand your logs, metrics, and APM data. At Elastic, we have a single platform from data collection to storage and UI, which allows us to bring these incredible experiences to life and help you become an observability champion at your company. I cannot be more excited about the progress we made so far and about what is coming next year. Back to you, Tanya.
Thank you, Alex. That was really exciting. Next, I would like to welcome Drew Post, product lead for Elastic Digital Experience Monitoring. Drew is going to talk to us the importance of ad hoc analysis and machine learning and raw access to data when it comes to answering some of the most important questions, but at the same time, ease of use when we work with this data. Drew, please take it away.
Thanks, Tanya. Simply put, between our highly scalable searchable data store and the powerful capabilities built on top of our Elastic Stack, Elastic's comprehensive observability solution enables you to store vast amounts of data and then leverage it to help answer any question you might have. Whether it's infrastructure level data such as logs or metrics, application level data such as that from APM, or even front-end user experience data like synthetic test runs or real user monitoring RUM. We obsess over that experience of getting the right fidelity of information about the performance of your applications from the smallest piece of your infrastructure all the way through to what your app looks like when it's rendered on an end user screen. Whether you need an answer quickly or if you want to deep dive into your data to validate a hypothesis or you're just generally curious, we believe that not only should data not be locked away in silos or proprietary data stores, but that using it to answer fundamental questions is a key capability of our product. It enables a democratization of data to answer your critical business questions without requiring a degree in data or computer science to access and understand it. So what does that look like in practice? Well, something like this. As my colleague Alex just showed, at the highest tier of information fidelity, we use the powerful out-of-the-box machine learning and statistical analysis capabilities built right into the Elastic Stack to drive rich anomaly detection and root cause analysis. This includes anomalies that are transient or even identifying when specific cohorts are consistently underperforming on your site or application. We deliver quick insight to reduce that mean time to detection. This high-level insight is backed by a slightly richer level of fidelity delivered as clear charts and graphs to help users quickly get to the answers they need in order to resolve a problem. The real beauty of Elastic Observability, however, is that it enables any user of our product to get actionable insight from their data. I kind of like to think of it as us doing the heavy lifting for you, identifying an anomaly with those out-of-the-box machine learning jobs or even your own custom jobs, analyzing the countless dimensions within the data to surface up potential answers, like the correlations capability with an APM, and also measuring the impact of any changes. All of those things improve the mean time to recovery, and minimize the impact of anomalies on your end users. Now, this used to require countless hours of manual investigation, but with Elastic, you can do it at the push of a button. And to be honest, for most situations and people, this will be enough. We are all busy. We don't really have time to dig into the data for fun. We need answers and we need them now, or sometimes yesterday. But what if you do need more? What about those unknown unknowns that crop up that you couldn't possibly account for with pre-made dashboards or out-of-the-box machine learning jobs? What if you're an analyst who wants to use their expertise to maybe conduct some investigations? Or what if you want to test a hypothesis that you've come up with, or just want to explore the data to see if you can identify anything that's interesting? Maybe you can then write a blog about it, or use it to build a business case for investing in performance or optimizations within your company. This is where the next level down comes in, the curated data exploration view. This is a truly unique capability. Many products out there let you look at data in this way, but you're really usually limited to a single dimension of data. And as we all know from the increasing complexity of our applications, a signal that you detect on the front end could actually be originating from something in the infrastructure or application code. This could be being observed by a completely different set of tools. Being able to see this data side by side with full control over filtering, breaking it down, and all of it using familiar terminology without really needing to know anything about index patterns or field names means that we're bridging the gap that's traditionally existed between the data and getting answers from it. Let's take a look now at how this works in a real world scenario, because it's really quite cool. So here I am in our brand new user experience dashboard that we have within observability. This is showing me the front end performance based on the RUM data captured from our APM solution. Now it shows me interesting things like page load duration, high-level metrics, some really useful information like our core web vitals. These, by the way, are the signals that Google uses when they're doing page rankings based on page performance. So super important to keep on top of. And then we've got some charts and graphs. And obviously, looking at this chart here, something massive jumps out at me. There's a giant spike here. Now, this is showing me the performance of the entire population. But anybody who knows kind of front-end RUM data knows that there is no one single solution. There's a breadth of experiences that someone has. So I want to maybe investigate this a little more manually because the answer isn't here in this chart. So what we've done is in the product, we're moving all of our charts to include this new Explore button. If I click it, we'll actually open that same chart in our brand new exploratory view. And you can see here, I've got that same chart and I've got a whole new set of controls around it. Now, I can see the spike, and the first thing I want to do is start breaking it down by some sort of a reasonable dimension. So I go down here to the series in the bottom, which is showing me the RUM data, click the pencil, and I'm shown a bunch of different options. I can filter by a URL, I can change the time period. I can even start filtering by different things, like filtering by different applications, different device types, different browser families. All of these can tease things out to extract data. But what I'm going to do first is I'm going to go to the breakdown menu, and I'm going to break this down by device type to see if any particular device type is jumping out. And we'll go ahead and click Apply Changes. And yeah, wow, that's pretty obvious right there. So that spike is maintained only in one of these populations, and it looks like it's mobile users. So whatever's going on here is affecting the mobile users on my website. I can tell this from the RUM data. But there's so many things it could be. I need to start looking a bit deeper. So the first thing I want to do is maybe use synthetics data, which is always about clean consistency, to establish a baseline and see if it's occurring in there and my synthetics data that's come back. So I'm going to go down here and click Add a Series. I'm going to add synthetic data type from synthetic monitoring. And I'm going to keep the same metric. So we're just looking at page load duration right now. We'll look at that. And it should give me some controls. Let me just choose the monitor our product checkout flow. This monitor basically includes all the key pages on the website. So if something's happening, it'll probably be showing up in this monitor here. And then I do want to filter this down. So I want to get rid of all the other test runs except for ones that are run as the mobile profile. So that way it matches up what I'm seeing in the RUM data. Apply that. So I've added a filter. I've done a breakdown. I've selected a specific monitor. I now am going to hit apply and actually see what that synthetics data looks like side by side with my RUM data. Let's go ahead and hit apply changes. And yeah, wow, I can see it right there. I mean, you can see, and again, remember RUM data, that each data point is like an aggregation of a bunch of different visits, whereas synthetic data is usually nice, single individual tests. So the shape looks different, but I can see there is a plateau about the same time that my RUM data was showing something weird going on in the synthetic data. So there's definitely something happening here. I've validated it with my synthetic data. I got the signal from my RUM data. Now I want to understand, is this happening in the front end, back end? Where is this going on? So what I want to do is take a look and see if maybe there's some increased error rates within my APM data. So I'm going to add another series here. And we're going to add APM data type. And like I said, let's look at error rate. And you don't need to filter, break anything down. I just kind of want a baseline kind of across everything, cast a nice wide net. So we're going to apply changes. And I can see, well, there's no spike there. So I can see the APM data showed up there as a red line. I don't see an increase in error rate. So what this is really telling me is that whatever's happening, it's happening once that response leaves my infrastructure. Something's happening either in transit on the end user's device that's causing this transient spike to show up. So I'm just going to take out the synthetic series and remove the APM series because I don't need them anymore. So I've established, kind of where the issue is. And I'm going to go tweak the RUM data a little bit more. So I'm going to expand this a bit. And I think I want to change my breakdown. The next thing I'm going to look is URL. Is it happening on specific parts of my site? So I'm going to break down, instead of by device type and break down by URL group. And we do a bit of clever grouping here that uses semantic URLs and kind of groups things together. And then I'm going to filter it as well, because remember, again, it's only happening in mobile, so I don't really need the noise of anything happening in tablet or desktop. So now my RUM data set's filtered to mobile and broken down by URL. Let's apply those changes. And I can see here, okay, wow, there's definitely a spike. And hey, fortunately, it's only in one specific page category. It's my product pages. So any URL that includes /product/ is having this issue. Right. Really interesting stuff. At this point, I've used data from 3 different silos to identify an issue, understand who it's impacting and what's being impacted. From here, I can take a number of different steps. Using my domain knowledge as an analyst, I know that an issue impacting only mobile devices that's not showing in the infrastructure or application data means something is occurring on the page itself that's causing this issue. Given that it's recently appeared and then gone away on its own, and that it's only impacting a subset of users, i.e. those mobile users on the product page, I'm inclined to think that maybe something was pushed onto the page. This could be a number of things. It could be a bug in a recent release that was rolled back. Perhaps a new third-party snippet of JavaScript was even loaded by someone in the marketing team via the tag manager. To validate this, I can go look at recent release activity. I could go look at a synthetics waterfall to see if I can identify an offending object. I can also use the actions capability of the exploratory view to trigger a correlations analysis. I can then share this with a colleague. I can create or add the chart to a case. Or even if I need more power, I can even open this up directly in Lens for more detailed information and access to the full set of my data in the Elastic Stack. So the demo I just showed included data from the front end and a bit of APM, but of course, this works across the entire set of observability data, infrastructure and full application data layers. You can easily spot things like version inconsistencies, resource constraints, and so on. Now, this capability is available in a technical preview phase today in our product, and is expected to become generally available really soon. I hope that you find it as cool as I do. That's our data fidelity and ad hoc analysis in Elastic Observability. And now back over to you, Tanya.
Thank you, Drew. This was great. It's truly exciting. This is what I mean by democratizing the data, making it work for you as opposed to the other way around. Next, I would like to welcome a very important team member who's been at the forefront of industry-leading initiatives around open standards. But before I introduce him, I'd like to just say that openness has been a core tenet for how we build and advance products at Elastic. And in the context of observability, you can see on this slide that we've supported open standards and even de facto open standards for a number of years. We supported open tracing and W3C trace context, open metrics, and even de facto standards like Jaeger and Prometheus. And in Elastic, all data is truly first-class citizen. Everything is aligned to Elastic Common Schema. And you can view all of it in the Elastic Observability UI. So next, I would like to welcome Cyrille LeClerc, who's been a very important member of Elastic's team that's been engaging with you and with the community around efforts like OpenTelemetry. And he's going to tell you more about this important topic. Cyrille, please take it away.
Thank you, Tanya. We will cover observability standards, viewing how 2 leading standardization trends, Prometheus and OpenTelemetry, are shaping observability strategies on architectures, way beyond the question of vendor lock-in, how they will help drive consistency in observability, and how often they solve unexpected problems thanks to their popularity, their communities, and their ecosystems. Let's begin reviewing how open source and open standards are the DNA of Elastic. All of our products have their roots in open source: Elasticsearch, Logstash, Kibana, Beats, and APM. Many of them have created communities and ecosystems. A great example is the versatility of Logstash, with all the data sources, transformations, and destination it supports. This versatility could only happen thanks to a vibrant community and ecosystem, bringing years after year new capabilities. For open standards, we have always been early adopters of observability standards. FluentD, Prometheus, Open Tracing, W3C Trace Context, Open Metrics, FluentBit, Jaeger, and now OpenTelemetry. So let's see how these 2 critical trends, Prometheus and OpenTelemetry, are shaping the world. And then I'll present you the strategy of Elastic for CI/CD observability, how we leverage OpenTelemetry, its community, and its ecosystem. Let's start with Prometheus. Prometheus is so well established that we can jump to the conclusion. It's a de facto standard to collect observability metrics with a vibrant community and ecosystem. Let's look at an architecture diagram to understand what Prometheus is. Prometheus is first the time series database that everybody has in mind to store metrics, and it's also this ecosystem of the data collection layer, which started with a node exporter and then extended with integration built for traditional middlewares with these node exporters, converting the proprietary format of metrics into the standard Prometheus model. And now we see a generation of Prometheus native applications and middlewares which directly expose using the Prometheus format. All this success has only been possible thanks to the specifications of Prometheus. On the data collection layer, the Prometheus exposition format with this HTTP URL / metrics that expose the metrics and their values. On the backend side, the Prometheus query language PromQL that enabled the creation of this ecosystem of dashboards and alerts. And now we see also SLO solutions. Let's review how to integrate Elastic in a Prometheus architecture. So the simple model is to just use Elastic Observability as a storage of your Prometheus metrics. You benefit of the Prometheus ecosystem on the data collection layer. On the backend, you have Elastic Observability, bringing all the power of our unified solution that we are presenting today. Another model is to also keep the Prometheus time series database to store your metrics, so that in addition to the previous pattern, you also benefit of the Prometheus ecosystem on the backend side with PromQL, the ecosystem of dashboards, of alerts on SLO solutions if you want, and you mirror your Prometheus metrics in Elastic Observability to get the best value also of Elastic Observability. As a conclusion, Prometheus has changed observability, becoming a de facto standard to collect observability metrics with this vibrant ecosystem, and Elastic is fully integrated in Prometheus architectures. Now, let's review the second open standard, OpenTelemetry. OpenTelemetry, also called OTel, unifies observability, unifies all layers, infrastructure, application, and user experience monitoring, and unifying all signals, traces, metrics, and logs. It's also a CNCF project. It's much younger than Prometheus, but it has already a great impact on the observability landscape. The mature area of OTel with growing adoption in production is traces, when logs and metrics are emerging but not yet stable. Let's review an architecture diagram to understand the scope of OpenTelemetry. Similarly to Prometheus, OpenTelemetry is a data collection ecosystem. So OpenTelemetry produces APM auto-instrumentations on SDKs for the most popular programming languages of your applications. And we see an emerging, small but emerging ecosystem of applications on middleware that starts embedding the OpenTelemetry SDK to become OpenTelemetry native, directly export their traces and metrics and soon logs using OTel. And the third dimension is the OpenTelemetry collector, which is here to collect the metrics and logs typically of your system. And all this collection layer is interoperable thanks to the standardized APIs, standardized data formats and transfer protocols, and also, which is very important, standardized semantic conventions to normalize the data, normalize the names of the attributes, names of the metrics, enabling correlations between systems and fostering interoperability. So in the first architecture diagram to integrate OpenTelemetry, you see that the observability backend is directly the recipient of all the application and systems instrumented with OpenTelemetry, just picking the OpenTelemetry protocol. The second pattern is more sophisticated. And we see this pattern often emerging when people adopt OpenTelemetry. This architecture creates a backbone to channel all the observability signals, The signals are normalized on reach at ingest time using OpenTelemetry standards, including OpenTelemetry semantic conventions, so they can easily be consumed by every OpenTelemetry capable system. The observability backbone typically relies on a streaming technology like Kafka. On the consumers on observability backends can either expose an OpenTelemetry endpoint to be connected or directly connect to the streaming technology to the Kafka stream. Now let's review the maturity of the OpenTelemetry ecosystem and standard. So we have seen there are varying levels of maturity, with traces being the most mature when logs on metrics are less stable yet. There is a growing community and a growing ecosystem, including vendors of practitioners, with many practitioners in production today. And it's an emerging standard for observability architectures, as we can see with this very interesting diagram. Now let's review how Elastic fits in these architectures. The first model is very straightforward. Elastic Observability is an OpenTelemetry native solution. So you just connect your applications and system to Elastic Observability. And it's important to have in mind that you can mix and match instrumentations with Elastic technology on instrumentation with OpenTelemetry technology. For the more sophisticated architecture, Elastic is one of the observability backend of the architecture. As a conclusion, OpenTelemetry is still an emerging standard, but the adoption is growing fast and it's already influencing observability blueprints. And as a broader conclusion, Prometheus and OpenTelemetry are both very important and very popular standardization trends. They can help drive consistency in observability strategies, and they solve a growing number of problems thanks to the quality of their architecture and thanks to the vitality of their communities. Now I'll present the strategy of Elastic for CI/CD observability, how we leverage OpenTelemetry, its community and its ecosystem. Let's look at continuous delivery. It's a business critical problem. CI platforms are hard to keep up and running. CD pipelines are always changing and they continuously need optimization. And the workflows of continuous delivery combines many tools from many different ecosystems to build, to test, to deploy, and to run in production the applications. So it's a world of unknown unknowns that needs observability. And here the solution we have chosen at Elastic is based on the following principles. Open standards to connect these different communities and ecosystems, distributed tracing to model the CI/CD pipelines, metrics and dashboards for monitoring and measuring continuous delivery performance like mean time for build failure and repair, logging for traceability and troubleshooting. So it felt natural to take an OpenTelemetry native strategy to succeed here. And here is our journey after 9 months of work. We started with Jenkins and then Maven on Ansible and PyTest. We got immediate support from these communities, and we've been discovering and connecting with many other initiatives that are already growing here. And we see a proliferation of unexpected use cases. We discuss developer education, cost accounting on the CI platform, and as a summary, we get the full strength of this community-based strategy. And we have a great news to share with you today is that we will productize soon our CI/CD observability solution. As a summary, I hope I have convinced you that both Prometheus and OpenTelemetry are very important standardization trends. Their benefits go way beyond the question of vendor lock-in or the problems they solve in isolation, because they improve the overall observability architecture and they connect to communities and ecosystem. And also, I hope I convince you that Elastic is your best partner to succeed in both worlds. We are unfortunately short in time, but I would have liked to talk with you of other open standard strategies we have at the moment, such as our partnerships with Grafana and Confluent for Kafka, and our strategy also contributing to the OpenTelemetry iOS SDK. We will find another moment to discuss this. Thank you, Tanya.
Thank you so much, Cyrille. Well, this concludes really quick tour of the hot topics in observability. We hope that as you look through the rest of the sessions, you jump in to some of the deep dives on these and other topics and hear from both elasticians and users and customers like yourselves. Thank you so much for your time, and please enjoy the rest of the event.